Okay, so looking at our lesson for today, we're looking at triangle inequalities, which is something you guys kind of did out the Inspires already. We're looking to basically see if we can construct triangles with just any given random three lengths. All right, and I think that's something you guys found out very quickly on your in the activity. So the first three, were you able to create a triangle? Well, those first three examples. Yes, that is a question for you. What do you guys find out? Were you able to create a triangle? No. The first one? No. You weren't able to. So that's kind of really important because when we look at the two shorter sides, how did their sum compare to the third side? Yeah, their sum was always less than. So what we're going to do today is we're going to talk about that first bullet first, and then we'll talk about how to actually find possible lengths of the third side. And then we're going to learn how to actually compare two different angles and sides and stuff like that. So don't put your Inspires away. We will be needing those. But let's go ahead and move right into what we were just talking about here. So on the first three examples from that activity, you guys realized you couldn't make a triangle. No matter how hard you tried, there's no way to get all three of those segments to come together. And that's because we get into this law, this triangle inequality law. And what did you guys find out in the fourth one? What has to be true? There you go. The two smaller sides must be greater than the third side. In fact, it's not necessarily the two smaller sides, but any two sides. So we look at our notes for today. The one thing I want you guys to really get is this concept right here. The sum of any two sides of a triangle. Sum of any two sides must be greater than the third. That is the big idea for today's lesson. Sum of any two sides must be greater than the length of the third side. So let's go back. So if I had the statement AC plus CB must be greater than what?
AB.
Must be greater than AB. Very good. So AC plus CB must be greater than AB. What about the next one? AB plus BC must be greater than AC. And finally, AB plus AC must be greater than
BC.
So the sum of any two sides must be greater than the third side. Otherwise, you can't get a triangle. It's that simple. So if I'm looking at example 1 and we have the lengths 3, 7, and 8, can I make a triangle with lengths 3, 7, and 8?
No.
And how would I verify this? Okay, guess the one we just wrote down. What's the theorem for today say? Look at your notes you just wrote down. What does it say?
The sum of any two sides is greater than one side.
Alright, so and typically we're talking about the shorter sides. So what are my two shorter sides there in example 1? So we need to check. Is 3 plus 7, we'll put a little question mark, is 3 plus 7 greater than
Yes.
8? Well, what's 3 plus 7?
10.
Is 10 greater than 8?
Yes.
Then yes, this makes a triangle. Okay, let's look at example 2. What are my two shorter sides in example 2? 3 and 6. So does 3 plus 6, is that greater than 10? No. Therefore, not going to make a triangle. What about the last one? Is 2 plus 7 greater than 9?
Yeah, no, it is.
It's the same, it's equal to it, but is it greater than that? No. So, therefore, again, this is a no situation. It must be greater. Can't be equal to. It has to be greater if you're going to make a triangle. Alright, does that make sense? That's pretty much all we're talking about today.
Yeah.
Okay, Jackson?
Can you repeat the name of the theory?
Yeah, it's the triangle inequality theory, or theorem. Triangle inequality theorem. Okay, so I want you guys to look at this. We'll do an example 4. Hopefully you guys see a pattern that will make these problems a lot easier for you. I'm going to ask you a very simple question. If you have lengths 8 and 10, I want to hear from you guys. What are some possible third sides that could work? Lucas? 17. 17, does that work? Okay. What do you mean? 3? 3 could work? Okay, what else? What are some other ideas? Mackenzie, some ideas here what you think would work. Or how would you verify that? It's got to be less than 18, right? Why does it have to be less than 18? So 23 won't work? Okay, so it has to be less than 18. Okay, so that's actually good. You guys are kind of picking up on stuff pretty quickly. It's got to be less than 18. So what other options would work here? Would 12 work? And what about 5? What about 1? So Brian, what do you think?
Can it be equal to, or does it have to be more?
Has to be more than.
So it has to be more than 2.
So it's got to be more than 2. Would 2.5 work?
Yeah.
All right, so now we have an infinite number of possibilities, right? We're not just talking about whole numbers. We're talking about any value that makes it greater than that, correct? All right. So basically, what you just said there was very important, Brian. You said that it has to be greater than 2. Okay. So now what we actually say here, our final result is that the side 3 has to be greater than 2, but it has to be less than 18. What I want you guys to look at, where does that come from? Where does that come from? How do you find the maximum value? How do you find the minimum value? That's right. Alright, so the minimum is the difference, so 10 minus 8. And what's my maximum? Yeah, that's when you're going to add them together. So 8 plus 10. That's it. So guys, number 5 is real easy. What's the range of possibilities for number 5? We have 3 and 12.
I got a question.
Yes.
So why is some called theorems and some called postulates?
Postulates are assumed truths. They don't need to be proven. That's the difference. Theorems, you have to be proven. Okay, number 5. What do you guys think here? What's my minimum value? What's my maximum value? What's my range? Sarah?
I said your maximum value is going to be 15,
Okay.
and then your minimum is going to be 9, so then it's going to be 9 is less than side 3 and then greater than 15.
No, again, less than
15.
15. As if you write these out correctly, again, this is from math or from algebra 1. This is compound inequalities. Compound inequalities.